this is the reason why we think that now we have the necessary technology between Omniverse and all the computers that we built, these 3 computers, and the latest generative AI technology, that the time has come for humanoid robotics.
If you thought AI-powered humanoid robots were still a thing of the far-off future, think again. NVIDIA's latest innovation, the Groot workflow, is setting the stage for robots that walk, think, and act like humans. This groundbreaking tech could change industries and everyday life. But how close are we to seeing humanoid robots become a part of our world?
Let me talk about what's next. The next wave of AI is physical AI. AI that understands the laws of physics. AI that can work among us. And so they have to understand the world model so that they understand how to interpret the world, how to perceive the world. They have to, of course, have excellent cognitive capabilities so they can understand us, understand what we asked, and perform the tasks.
How is NVIDIA leading the charge? And how are they making humanoid robots a reality today? Let's dive in and hear directly from Jensen Huang himself.
Now, why is humanoid robotics so hard? Well, obviously, the software developed for human robots is extremely hard. However, the benefit is incredible. There are only 2 robotic systems that can be easily deployed into the world. The first robot is a self-driving car. And the reason for that is because we created the world to adapt to cars. The second is humanoid robots. These 2 robotic systems could be deployed in brownfields anywhere in the world because we created the world for us.
As Jensen Huang explains, creating humanoid robots that can perform real-life tasks is an incredibly complex challenge. Unlike the controlled environments we can design for machines, humanoid robotics demand software so advanced that it can adapt to the unpredictability of the human world. Take self-driving cars as an example. They've been easier to deploy because we've built the world to accommodate them. Roads, lanes, traffic lights, and signs all exist to guide vehicles. It's a system designed for cars to thrive. Now imagine humanoid robots. Our world is already designed for human interaction, making it possible for these robots to adapt. But the challenge lies in the execution. Building robots capable of navigating and functioning like us requires cutting-edge technology, intense training, and groundbreaking frameworks. Imagine teaching a robot to walk into a room, recognize faces, and serve coffee, all without bumping into walls. That's the challenge NVIDIA is solving with its Groot workflow. Starting with Isaac Sim, a virtual training ground for robots, this technology takes us one step closer to robots that can navigate the real world as naturally as we do. NVIDIA Isaac Sim.
Well, this last week, at the conference for robotics learning, we announced a new framework that is super important. It's called Isaac Lab. Isaac Lab is a reinforcement learning virtual simulation system that allows you to teach humanoid robots how to be humanoid robots. And on top of it, we have several workflows that we have created.
As Jensen Huang explains, the NVIDIA Isaac Sim trademark platform is a game changer for robot training and development. It's a simulation platform designed to help developers design, test, and train AI-based robots in a virtual environment that mimics the real world, without the costs or risks of testing in actual homes, as some other companies do. Built on NVIDIA Omniverse trademark, Isaac Sim is fully extensible. This means developers can create custom simulators using universal scene description, OpenUSD, or even integrate Isaac Sim technologies into existing testing pipelines. Simply put, NVIDIA Isaac Lab, an open-source application built on Isaac Sim, makes it easier to train robots using reinforcement and imitation learning techniques. Whether it's a simple task or the complex operations required for humanoid robots like NVIDIA's Project Groot, robots can fine-tune their skills and get closer to real-world readiness in this virtual lab. Now here's a question for you. Do you think NVIDIA's Isaac Lab simulation is as impressive and practical as it sounds for training robots to handle life's complex situations? Let us know your thoughts in the comments below. Now let's move forward to explore NVIDIA's frameworks, designed to make robots more efficient and bring their real-world applications closer than you might expect. Other frameworks. Groot Mimic.
The first workflow is Groot Mimic. Groot Mimic is a framework for demonstrating to the robot how to perform a task. You use human demonstration and then mimic that environment using domain randomization, generates hundreds of other examples like your demonstration so that the robot can learn to generalize. Otherwise, it can only perform that very specific task. Using Mimic, we can generalize its learning.
You heard that right, but get this. Humanoid robots as we know it are mimicking humans. For robots to replicate human actions effectively, they need to learn how to perform tasks across a wide range of scenarios. That's where Groot Mimic comes in. So, what is the Groot Mimic exactly? Groot Mimic is like a masterclass for robots. This framework works by generating large-scale synthetic data sets from just a small number of real-world captures. By analyzing just a few real-world actions, like opening a door or walking through a crowd, it creates millions of training scenarios, teaching robots to move and interact like humans. This means robots won't just walk, they'll learn to adapt to new environments with ease. It's like giving robots a crash course on human behavior and actions, using minimal real-world input to create vast amounts of training data. Innovative, right? Now let's move on to the next framework and see how it tackles a critical aspect of robotic training. Groot Gen.
Second is Groot Gen. Groot Gen, using generative AI technology in Omniverse, we can create an enormous number of random, domain randomized examples of environments and the actions that we would like the robot to perform. And so we're generating a whole bunch of tests, evaluation systems, evaluation scenarios that the robot can try to perform and improve itself, learn how to be a good robot.
Groot Gen takes robotic training to the next level. Imagine a robot practicing in thousands of different environments, from icy sidewalks to crowded subways. Using generative AI, Groot Gen builds these scenarios virtually, ensuring robots are prepared for anything the real world might throw at them. In simple terms, this framework is all about diversity. It generates learning environments and layouts that help robots adapt to a wide range of real-world situations. And if you're wondering what the NVIDIA Omniverse is, here's the answer. It's a physics-based operating system for physical AI simulation, enabling robots to interact with highly realistic virtual worlds. Now let's move to the third framework, which takes robot functionality to the next level. Groot Control.
And the third is Groot Control. Groot Control is a model distillation framework that allows us to take all of the skills that we've learned and distill it into one unified model that allows the robot to perform kinematic skills.
Did you catch that? Jensen mentions that Groot Control is a framework for neural full-body control. This is a big deal. It's a model distillation framework that consolidates learned skills into one unified model. What does that mean? It enables robots to perform complex kinematic skills, and coupled with another of NVIDIA's framework, Groot, dexterity for fine-grained and dexterous manipulation, some tasks requiring dexterity are possible, such as picking up fragile objects, navigating tricky environments, or even folding laundry and placing it neatly into a basket. Practical and impressive, right? Now over to you. What do you think about the functionalities of these three frameworks? Do you feel there's something NVIDIA should incorporate to enhance these systems further? Drop your thoughts in the comments, and let's discuss. Still on the subject, let's not lose focus. Jensen Huang's message is clear. The time for humanoid robots is now. Imagine this, just one robot making a difference today, but in the near future, factories will be orchestrating entire teams of robots, monitoring operations with thousands of sensors seamlessly integrated into their systems.
All of the factories will be robotic. The factories will orchestrate robots, and those robots will be building products that are robotic. Robots interacting with robots, building products that are robotic. Well, in order for us to do that, we need to make some breakthroughs.
When we talk about future factories, it's not a contradiction to say humanoid robots are already here. Take the Neo robot from the company 1X, for instance. It's actively being tested in real homes. Meanwhile, Elon Musk has announced plans to begin mass-producing the Tesla Optimus robots by the year 2025, aiming to deploy them in factories. That's not all. Figure 01, another humanoid robot, is already hard at work in BMW's Spartanburg factory. And if that doesn't impress you, let's talk about Ameca, the humanoid robot known for its shockingly lifelike facial expressions and human-like interactions. Recently stationed at a school in the National Robotarium in Edinburgh, Scotland, Ameca is engaging with kids and adults alike. At the Wii Robot event, humanoid robots, including Tesla Optimus, captivated audiences by interacting with people, dancing, and even serving drinks. These robots are not just limited to factories and homes. Humanoid robots like Sophia, the social robot, and Ameca have been making headlines, appearing in interviews and showing us just how advanced they've become. So, when Jensen Huang says, "The time for humanoid robots has come," he means it. Now, transitioning to how this revolution extends to factory digital twins, NVIDIA is leading the charge with an omniverse blueprint called Mega. Here's the fascinating part. Mega creates a factory digital twin populated with virtual robots and their AI models, essentially the robot's brains. Here's why digital twins are another unsung heroes of NVIDIA's robot revolution here. By creating virtual copies of real-world robots in spaces, NVIDIA ensures these humanoid helpers are ready before they ever step into the real world. It's like rehearsing every possible move in a perfectly simulated environment. Here's how it works. Robots execute tasks by perceiving their environment, reasoning, planning their next move, and converting those plans into actions. These actions are simulated in a digital environment using Omniverse's World Simulator. The results are then fed back into the robot's brain through Omniverse's sensor simulations, which guides the robot to decide its next action. This creates a continuous feedback loop, refining the robot's decision-making and efficiency. While Mega precisely tracks the state and position of every element in the digital twin, this software-in-the-loop process allows industrial enterprises to simulate and validate changes in the Omniverse twin before deploying them in the real world. This approach saves time and costs while minimizing risks significantly. Now let's dive into how NVIDIA ensures they deliver on creating physical AI. They've developed a streamlined three-computer system that empowers developers to bring physical AI to life. First, models are trained on NVIDIA DGX, a platform designed for handling the massive computational demands of AI training. Once these models are ready, they're fine-tuned and tested using reinforcement learning combined with physics feedback in Omniverse, NVIDIA's cutting-edge simulation platform. Finally, these trained AI models are deployed to NVIDIA Jetson AGX robotics computers, enabling real-world applications in robotics. So, what do you think? Does all this innovation convince you that the era of robots is truly here? NVIDIA CEO Jensen Huang has laid out a compelling case, but we want to hear your thoughts. Drop your opinions in the comments below, and let's keep this fascinating discussion alive. But before we wrap up, while humanoid robots represent incredible and exciting potential, it's crucial to acknowledge the warnings from scientists and AI researchers about a darker side: killer robots. If you haven't heard about this controversial topic, we've covered everything you need to know in our recent video. It's a conversation you don't want to miss. Check it out here.